Hello and welcome to this session. Today, we are going to explore how we can use the OFC trainer kit to change our voices into radio signals and back again. It's like turning our words into invisible waves that travel through the air and then transforming them back into sound. Let's dive in and see how it all works.
Objectives. At the end of this session, you will be able to explain frequency modulation and demodulation and demonstrate the frequency modulation and demodulation using OFC Trainer Kit by VoiceLink. Demodulation is defined as extracting the original information carrying signal from a modulated carrier wave. A demodulator is an electronic circuit that is mainly used to recover the information content from the modulated carrier wave. Need for demodulation. Demodulation is the process of recovering the original signal from the modulated signal. The modulation of the signal is done to transmit the signal over long distances by decreasing the bandwidth requirements. It also helps in multiplexing, which means that multiple signals can be transmitted over a single channel, resulting in efficient use of the spectrum. The modulation is done with the help of radio frequency, which is outside the audible range of the human ear. To retrieve the original information and make it in the audible range for humans, the demodulation process is required. Different types of demodulation. They are amplitude demodulation, frequency demodulation, and phase demodulation. Frequency demodulation. Frequency demodulation, also known as FM demodulation, is the process of extracting the original information signal from a carrier wave that has been modulated in frequency. Types of frequency demodulation. They are slope detector, ratio detector, and phase locked loop or PLL. Slope detector. Slope detection is a simple method used for frequency demodulation. It relies on the fact that the frequency deviation in an FM signal corresponds to changes in the signal's slope. Operation. The FM signal is passed through a circuit that detects changes in its slope. The output of this circuit is proportional to the frequency deviation, and thus the modulating signal can be recovered. Ratio detector. Ratio detection is a more sophisticated technique that compares the phase difference between the input FM signal and a local oscillator. Operation. The input FM signal is mixed with a local oscillator signal at the carrier frequency. The phase difference between these signals is then compared and the output is proportional to the frequency deviation. Phased locked loop or PLL. A phased locked loop is a widely used demodulation technique for FM signals. It locks onto the phase of the carrier wave and tracks its frequency variations. Operation. The incoming FM signal is compared with a voltage-controlled oscillator or VCO output. Advantages of demodulation. It helps in the efficient use of the bandwidth by allowing multiple signals to pass through a single channel. It helps recover the original signal, which is essential to retrieve the original information from it. It improves noise immunity, which helps in improving the reliability of the signal. It can demodulate the AM, FM, and PM signals. This helps in improving the diversification of demodulation and can be used in a wide range of applications. Applications of demodulation. Radar system. The demodulation technique is used in the radar system to extract information about range, angle, and many more. It helps in navigation, weather monitoring, and defense. Television. The demodulation technique is used to recover the video and audio signals, which helps in proper displaying of the television programs. Radio broadcasting. Demodulation is used to extract the audio signals which is to be broadcast. It can retrieve AM and FM signals to broadcast over a wide range of frequency spectra. Underwater communication. For underwater communication, acoustic signals are used. These signals need to be demodulated to receive the original information coming from the deep sea. Medical. The demodulation technique is used to generate the image of internal organs. It is widely used in MRI and ultrasound. Next, we will perform FM modulation and demodulation using OFC Trainer Kit by VoiceLink. For this, you will need the following tools and equipment such as Optical Fiber Communication or OFC Trainer Kit 1 number, Fiber Optic Cable 1 number, banana pins as required, mic 1 number. Now let's see the steps to perform FM modulation and demodulation using OFC Trainer Kit by VoiceLink. Power supply connection. To ensure proper operation, let's start by establishing the power connection for the OFC Trainer Kit. Begin by plugging in the power cords of the device into the power outlet. Double check that the power switch is in the on position before proceeding. Connect the microphone. The first step is to connect the microphone to the audio input circuit of the OFC Trainer Kit. This will enable us to input the audio signal that we want to transmit through the optical fiber communication system. Ensure that the connections are securely made to prevent any signal loss or interference. Connect to frequency modulator. Next, let's prepare the voice link for modulation by connecting it to the frequency modulator. For this, locate the output port of the audio input circuit on the OFC Trainer Kit. Using a suitable cable, take the output signal from the audio input circuit and connect it to the input port of the frequency modulator. Prepare for transmission. Now connect the output of the frequency modulator to the input of the emitter circuit. Use a suitable cable to connect this output port to the input port of the emitter circuit. The emitter circuit likely has different operating modes, including analog and digital modes. For transmission through fiber optic cable, we need to set the emitter circuit to digital mode. The next step is to connect one end of the fiber optic cable to the emitter circuit's output terminal. Next, we will connect the other end of the fiber optic cable to the input of the detector circuit. Ensure the fiber optic cable is connected at both ends. Safety tip. It is crucial to handle fiber optic cables carefully to avoid damage to the fiber strands or connectors. Demodulation setup. Connect the output of the detector circuit to the input of the comparator circuits. Ensure that this end of the cable is terminated with appropriate connectors compatible with the input port of the comparator. Next, we will connect the comparator's output to the input of the phase locked loop or PLL detector. Use suitable cables or connectors to establish this connection, ensuring that the signal path from the comparator to the PLL detector is properly connected. Observe demodulated signal. Next, we will connect the output of the PLL detector to the input of the low-pass filter circuit. The low-pass filter circuit helps remove any high-frequency noise or interference present in the demodulated signal. Next, we need to amplify the filtered signal to achieve a suitable amplitude for observation. For this, connect the output of the low-pass filter circuit to the input of the amplifier circuit using appropriate cables or connectors. Retrieving the original signal. Now connect the output of the amplifier circuit to the input of the audio output circuit using suitable cable. Listen to the demodulated signal. To listen to the demodulated voice link, we have to connect the headphones to the output of the audio output circuit. Without headphones, we can directly hear the voice link from the audio output circuit block using the inbuilt speaker.
Fiber optic communication. Fiber optic communication. Okay.
This brings us to the end of this session. In this session, we have learned frequency modulation and demodulation, and demonstration of frequency modulation and demodulation using OFC Trainer Kit by Audio Signal. Thank you for watching. We will see you in the next session.